Hi, today is 11th November and today's Leetcode question is design graph with shortest path calculator. So first let me read the whole question. So there is a directed weighted graph that consists of n nodes 0, 2 and minus 1. The edge of graph are initially represented by edges. So from, to and edge cost. So let's say that here is a graph, here is an edge 0 to 2 and the weight is 5. So we are given this edge and we need to implement a class graph. So we will first initialize the graph with given n and edges. The second thing is they are saying is they need to add edges. So in between we can add edge between two vertices, and it is guaranteed that earlier there was no edge previously, and now in the meantime means they can ask for shortest path between two given nodes, so node 1 and node 2. So and if they are connected means if there is a directed graph, directed path from node 1 to node 2, then we need to find the shortest path from node 1 to node 2, and if it is not connected means if there is, then if there is no path from node 1 to node 2, we need to return -1. That's it. So this is the question. So we will initialize the graph, we will add the graph. That is, I think, that is simple, but we need to keep calculating the shortest path between node 1 and node 2. So there are many ways to calculate the shortest path from one vertex to another vertex. First, let us check the path's cost, which means weight, whether that is positive or not. Here it is mentioned the edge cost is from 1 to 10 to the power 6, which means that path is positive, weight of the each edge is positive, which means we can use Dijkstra algorithm. So it's Dijkstra algorithm can be used to find the shortest path from one to from one node to another node. Let's just jump in and then I'll code it, and while coding I'll keep explaining, and wherever I think a comment is needed, I will put the comment also, so that it is easy for later on to understand the whole code. Okay, let's start. So first we need to initiate the graph. So how is the graph? So we will use adjacency list for this. So it's like something like if we have 0 node, this is indicating a 0 in vertex basically, or node. So we need to find what all the vertices that we can traverse from 0. So let's say from here in this graph, let's say 0, I can go to 2, I can go to 1, yeah, so 2 and 1. So I will be saving 2 comma and its cost like this 5, and then I'll have 1 comma 2. So this is the representation that I am going to use for my graph. This is adjacency list representation. I think it is quite a popular one also. So we will have a vector of vector of vector for my graph. Okay, and I will keep it in the private part for the to be accessible by all the methods. So graph is my basically this, and it has n what and nodes 0, 2 and -1 nodes are there. So this is my graph. Now I will connect the edges from the graph, and it's very simple. Let's say graph, there is 0. I will keep adding the edges. So basically what all edges, what all vertex that can be traversed from the current vertex and its cost. So I am just adding it. So my graph is ready. This is my graph. I will need n, so I will just save n also for later on, so that I can use it. So this is the initialization part. We init the graph. Now let's say someone asks us to add an edge. So what will I do? So it's similar to this, right? I will do this the same. There will be given from vertex to vertex and the cost of the this edge. So I will add. Now I need to find the shortest path, and I am going to use Dijkstra algo. So how does Dijkstra algo work? I think it's a fairly standard process, a standard algorithm only that we are going to use. So it has a priority queue, right? And we need two things in each of the item of the priority queue. Why? For example, in priority queue, I will need something like, for a particular vertex, what is the cost that we have calculated. So let's say, so which means, so it will be like something like cost and vertex. So I will be saving this in the priority queue. So it will be vector of vector int. This is standard C++ priority queue initialization, right? This is my priority queue. First I will push the first vertex, right? And its cost will be 0 and node 1. Means I am trying to calculate all the paths from the node 1 so that I can reach node 2. I have pushed the first node inside the priority queue. Then I will also have a distance vector in which I will have the basically the distance of all vertex from node 1 basically. Yeah. So we will initialize it with a very high number. Let's say we can use anything. Let's say I use 1e9, which is 1e9 is nothing but 10 raised to 9. This is a big number, fairly big number, so that also why I am not using int max here, I will just explain in a bit. So I have just initialized the distance also, and obviously distance of the first node means node 1 that is given. I am assuming it to be 0 because from the same vertex, cost to go to the same vertex is 0. Now I will traverse the priority queue, right? Whatever is the first item, let's say top item, whatever at the top, I will keep it, I will pop it out, and then I will check what all vertex we can go from this top vertex top. Remember, top is each item is a vector which is cost and vertex, right? Now let's say I am able to reach my final node, which is node 2, my destination. Then I will just return top of 0. That's it. So it means I have reached the destination. Now I will traverse all the vertices, right? Let's call it's V, which are in the neighbor of the current vertex, which is top of 1, right? Now so this is standard Dijkstra algorithm that I am coding. So and if let's say my distance of V, which I have initialized all to a very high number, or if something is calculated is greater than what I am going to use now, which is top of what? Top of 0 plus the edge cost is V of 1, right? This is V of 0 because it's a graph here. Cost. So distance, if distance is greater, I will just reassign it because I have found a smaller path to it for traversing, right? And I'll push it in the priority queue. So when I push it priority queue, what will I push? I will push the cost part first, right? and then I will push the vertex. That's it. I am pushing. If I am getting the if it is equal, I will return the cost. If let's say I am not able to find anything, I am returning -1. Oh, here I can use actually 1 means 10 to the power 9. Why? This is, let me mention it clearly, 10 raised to 9. Yes, I can do int max also here because I think we are checking, and yeah, it will not harm. So let's just check. I will run it. I think this should work. Yes, for the first of the algorithm, first of the test cases, it is passing. So I will try to submit it, in which they have mentioned, yeah, it is passing all of the test cases. It is successfully passed. Now, more thing that I wanted to mention, this is in Raistra part, right? Now, what there is also another method to find the shortest path. Floyd-Warshall algorithm is the name. I don't think we should remember the name, but we should remember the algorithm, that what it mentions. So here what we are doing is we are finding the shortest path, right? Now, so each time when they will ask node 1, node 2, we have to do this whole. So how much time, let's say, it is taking. So I am pushing the shortest path. So it takes priority queue will I will push how many elements, let's say n is what, let's say number of vertex. So if I keep finding the better path again and again, then I need to pass. So priority queues generally take what, finding the top, and this creating, that will take creating is take order of n, but popping out take log n only, and maintaining also take n. So let's call it log of v, and we need to do for all the edges. Means we need to search, if let's say we keep finding the better. So all in all, it will take e log v time. Yes, which is e is itself. So let's say if I mention time complexity of this one, this part is around e log of v, right? And note that e is also order of n square into n square, right? E means number of edges is n square, so this is around taking n square log n time, or let's call it v into v, or let's mention v into n only, sorry, v as n, so e log n time. So overall, this is the term complexity, and edge itself is also, so this is n square taking. What we can do is, there is one algorithm which Floyd-Warshall, which in which we can recalculate the edges, recalculate distances, shortest distances between two vertices, and we can save it, and then whenever they ask, we can just return. And even while adding edges, we need to just upgrade to all the paths that are traversing through that edge only, so we can do that. So we will see that in the later video. That's it for today.